G'day, it's Clyve Roksingha here. This new video, this is a new video for mechanics, panel beaters, brake mechanics. You've got a circuit and you want to design a switch, or you want a 3D print switch for a car. My training, my profession, well, when I say professional training, I did two trades. But in my original trade as a panel beater, that's where I've got most of my fundamental education. So I think like a panel beater, and everything I do is with respect to being a panel beater, because that's how I was trained. They trained me for 4 years. So when you've had that sort of training, I mean, that's what gets you over the line. I'll always be a panel beater, even though I'm doing engineering and electronics. At the end of the day, I'm a panel beater, and I think like a panel beater, and so on and so on. So this is absolutely necessary if you're going to, as I say, wire a switch up for a vehicle, and you've got to set up a test circuit. And what I found is that, number one, my absent-mindedness plays into this big time. I have a lot of trouble with this, but as with mechanics and panel beaters, we do other things, a lot of other things. Electronics is not something that you whiz in 5 minutes and knock it over, and even though there's only 4 or 5 wires to it, you get it wrong and it goes up in flames. So you've got to be very careful how you set this stuff up. Now, although you look at that and say, oh, this is a fairly simple circuit, look at the crap. And that's all cleaned up. I had to find all that. It took me about 4 hours to get all this together. This is what you're looking at with electronics. So the idea of this video is to take you through this basic circuit, this digital circuit, and tell you what you need to do to get it working. Number one, keep it neat and tidy. See how I've got it all here? All neat and tidy. Now with your diode, it's got a long and a short lead, and that's why I drew that diagram. And you see it goes from positive. So you've got your, now how have I got it here? There's your positive line coming from your power pack red. You've got red going into your switch, through your switch, out of here, up to there, red input here. Now notice that's a thick lead. That's because as you increase the wattage in the circuit, every time you put stuff in the circuit, it raises the wattage. So your input and output leads, which it doesn't seem logical, is you got all these little thin leads, right? But you've got a real big, thick and thin lead on in and out, because that's carrying the wattage of the whole circuit. And that's how you've got to think of this. So it's important that you have different wattage leads. And these secondary wattage don't do. I can't show you at the moment. So you've got power going into here, right? Now that goes in through the 470 ohm resistor, which is over here. As you can see, positive, 470 ohm. It goes through your 470 ohm, it comes down into that terminal there, that goes down into this one here, which is your green, and you see it goes from that one into the next terminal here, and that one goes up to the left hand side of your LED, and that part of your LED is the negative side of the LED, you see from the cap on the top there, and then that traces back to negative. So you're on the other side here, that's going through that side, it goes through the LED, it goes down here, it traces all the way back down to this terminal here, and so you've got your input and output lead here, that's your black one, and that's your power lead, and that traces back to the power supply, down here. It's got 2 switches on it, it's got a switch on the power supply, can't see it. There's also a switch here, which is, I really want to have removable names. And this is the stuff that you've got to work on now. This is a critical point here. This is absolutely critical. What you have here is clever control. Those circuits, these boards are designed to only handle a certain amount of wattage. And I call this a high current tower. The idea of it is you can design circuits with it. Once you start adding components to this and you start adding all sorts of bits and pieces, the wattage exceeds this board. End of story. So you're limited to only designing toys. So as soon as you start to design the thing which is going to be this thing, this is your moderate version, when I start building that tower, which is this one here, there's going to be a lot of electronic circuitry in there, and it's going to drive the wattage over the capacity of that board. So the whole idea of the high current tower is you can design the whole circuit for it. So I'm going to be able to go all the way through with this and design this circuit for this, and actually have quite an elaborate amount of stuff on it. The idea of this video is this is a primer video so that you can see what the circuit is. You can see it up and running. Did I have that turned on? On. Is that what's going on here? Did I connect that? On. Don't tell me I fried it. What have I done here? Oh, there you go. There you go. Oh, the batteries are getting a little bit low. Right. And there you have it there. So you have a digital LED switching circuit, and the reason it's got to be digital is because even the wattage, even the heat coming from a regular bulb will melt the PLA. So PLA is really, it hates heat. So even when you design this, you've got to keep the LED well away from the PLA. So, yeah, and this is what you're looking at when you're trying to design a very simple circuit. Because once you start adding components to it, the other issue is dirty power. If you want to plug this thing into the wall or have a supply that's permanent for your house rather than solar powered, I came up with this design, which is a power pack, and it sandwiches the output into a terminal like that, and you can treat it like a power supply. Why is that problematic? And this is something I'm going to have to do a test with, is parasitic capacitance. When you're doing switching circuits, it doesn't matter. But when you're dealing with transistors, stray capacitance is hell on earth. So my video's about to get cut off. So you've got to keep stray capacitance down or minimum. So those power supplies are a real problem with that. And you've got to have suppression. Anyway, this is the first of an instructional video in designing a digital LED for a vehicle or something. Clyve Roksingha, over and out.